The Universal Model, Volume 1, The Earth System, Chapter 2, Methods, Models, and Pseudo-Theories, Chapter 3, The Dark Age of Science, and Chapter 4, Scientific Revolutions.
Welcome. Good morning. I'm excited to be here with you guys and to have this opportunity to talk again about the introduction to the Universal Model. This is the first 4 chapters of the UM, and they really are important to us and give us an opportunity to understand the big picture of both modern science and the Universal Model. Today we're going to be talking about Chapter 2, 3, and 4, Methods, Models, and Pseudo-Theories, the Dark Age of Science, the Scientific Revolutions. And as we go through, you'll see us once in a while, we'll pop up and the learning process will continue. We'll learn this through our whole lives now. This is really an opportunity that people around the world don't have a chance to understand what knowledge and what wisdom are. Last time we got together, we talked about this. The physical side of life is what describes what, where, when, and who. Those are the 4 questions to understand the physical things of life that get described. Over here, we also have how and why. These are the 6 questions that all questions can be put into. And these 2 are an explanation, and this is what wisdom is. It's an intangible side of life. So I'm going to ask you, how do we do this, or why is this? And it gives us an opportunity to see how this fits in our learning process. One thing I wanted to explain also is that when you're going through the Universal Model and you're finding pictures, and a lot of times the text is pretty detailed, and I don't want you to feel overwhelmed. So what we ask you to do is when you come to an image like this, is there's a figure description right above the image, or usually it's going to be right below or next to the image. That figure description is a summary of everything on that page and the topics that we're talking about. So this is an easy way, especially moms and dads, if you have a younger child, to encourage them just to look at the pictures and read what's below them. And this gives you a quick summary of what's in that chapter you're looking at. Okay? So that's a real easy way to get familiar with what you're reading in the chapter first. Okay, so I'm going to go, if you got your book and you'd like to go along with us, we're going to go to page 23. This is Methods, Models, and Pseudo-Theories. We're going to talk about these here. So as you go to read through here, this particular chapter is going to be real important because the very first section is what we call a subchapter there. It says the line between theory and natural law. So theory and natural law is defined here. And this, you'll notice in all the chapters of the book, if there's any words that need to be defined, either we don't use them very often or we need a correct definition of that word, you're going to see it happening right at the beginning of the chapter or the subchapter. Okay? So one of the things we talked about last time briefly, I think I did, I'm not positive that we did, but this is going to come up when we get to the Dark Age of Science, is there's a big picture in modern science, and this big picture has 6 little boxes here you can see. And this is the problem. This is why we're learning correct science through the Universal Model. And that's because modern science teaches that man came from an ape, which came from plants, which comes from chemicals, which comes from a Big Bang, which comes from nothing. How does something come from nothing? It doesn't. That's right. So that's the problem with modern science. Okay? Teaching everything came from nothing is a pseudo-theory. That's a false theory taught as fact. You want to memorize that, what a pseudo-theory is. Pseudo means false. So a pseudo-theory is a false theory. And they teach it as fact that something comes from nothing. And of course, this is illogical. Okay? So this is why we are involved with learning correct methods, models, and also about pseudo-theories, how they've been taught. So on page 23 there, we're going to also look at some of these blue words. Okay, if we look on the second column of page 23, it says, notice the following quote from the book Truth and Science, how these 2 words appear together. The line that separates, this is the blue words, that separates the laws and theories of science from the factual evidence is not sharp. Okay? What that means is there's not a clear way to show what the difference between laws and theories are. So we're going to find out a little more about this. On this next page over there, if we look in the New Collegiate Dictionary, we find that it says the definition of the word law with respect to nature and science asserts a statement of order or relation of phenomena that, so far as known, is invariable under given conditions. A relation proved or assumed to hold between mathematical or logical expressions, the observed regularity of nature. This is an older dictionary. Newer dictionaries today don't clearly explain what law is. Matter of fact, it's very difficult to go in a modern science textbook and to find a correct definition of law. And there are reasons for that. We'll learn a little bit as we go along here. But laws are really important, and we give a couple examples over on the second column there, right above against method. So we ask ourselves, when is 2 times 3 not equal 6? See, we can look at mathematics and say 2 times 3 equals 6 yesterday. Does it equal 6 today? And what about tomorrow? Yeah. So this is passing the test of time, and it's part of something that we've talked about before. It tells us what truth is. Truth is knowledge, and it describes these things. For example, a living human body contains water. You notice that's the second item down there. That is something that is the same yesterday, it's the same today, and tomorrow. The same thing about how we describe a cube. A cube has 6 sides. And so these are things that give us order, and they're things that we find in nature that don't change. And this is what truth is. So the next subchapter we actually go into there talks about a false philosophy. This is on the bottom of 24. Before we get into that, let's read the gold words here. We look at the gold words there on page 24. And so we have a definition of natural law. Is a statement of an order or relation of phenomena that, so far as known, is invariable under the given conditions. Who thinks they know why we have that so far as known is bolded? When we start out with a theory, okay, do we know the answer? Okay, no, we don't. And sometimes a natural law can be put in place, and we don't know until way later on that actually there are conditions where the law might not stand. And that's because we have better observations, we have better technology so we can see things more clearly, and we just need to define it or tweak the law a little bit. So that takes place. That happens once in a while. And that's why that so far as known is bolded in there. Okay? And then, of course, on the next page, page 25, we ask the question, does it stand the test of time? This is really important for us to understand how we can discern between truth and error. It's something that doesn't change. So let's go over to subchapter 2.3. You can see that in red there on page 25. And what that says there in the heading is textbook confusion, the scientific method. So what we do is we actually have on the next page there, and starting in the bottom of the page, we have several examples. If you look at the blue words there, you can see several examples of how modern science has described the scientific method. There's a problem with that, though. The scientific method is supposed to be a method that we can use in all the sciences. And that's not what we find today. If you Google scientific method, are you going to find some steps that tell you how to do the method? And everybody uses the same method? No. Very good. Someone had their head going back and forth up here. That's right. You're not going to find the same method. It was very interesting to me when I went in and started searching this. I started doing the scientific research way before we had the internet. So it was difficult to find. I had to go into textbooks, and that's why we give all these different textbooks. We got chemistry textbook here, general science textbook, geology textbook. And each one of these textbooks, if you look on there, you'll notice that they have a bunch of different ideas there of what the scientific method is. Let's look at the very first one on A, for example. Says it starts with a theory, then there's a hypothesis, then there's independent and dependent variables, then there's experimental controls, then assigning participants to groups, then bias in research, naturalistic observations, surveys, and case studies. That sounds a little confusing to me because you go down to a next one, which is out of the physical geology exploring the earth, and it says that this scientific method to them is gathering and analyzing the facts. And then a hypothesis formulated, and then hypothesis is tested to see if it predicts, and then you end up with a theory. So do you start seeing, if you look at all these, the confusion that takes place? And this is what happens, Mom and Dad, is we purposely go to school to learn something. How do you learn when you're confused? It just doesn't work. And so that's why we showed you here, you can Google it and you're not going to get one method. There's no universal scientific method in modern science. And that's the truth that we're trying to get out here, and it's very important. So we go through and explained all these. There's on page 27, controversial science. It's very interesting. Here's one. It says that this seems self-evident. It says on the top of page 28 in the blue there, it says if we stop doing experiments, we'd no longer be doing science. Well, that's a very important statement because it turns out that there's a lot of scientists that don't do experiments. Most people do not realize, we go more into detail in this in second volume and especially in the third volume where we have a whole chapter on relativity. This is Einstein. Most people know who Einstein is, right? But we actually challenge whether Einstein was even a scientist or not. We state that he was not a scientist. And the reason we do that is because guess how many experiments he did? None. And that's very important. Like we just read there, if we stopped doing experiments, we would no longer be doing science. He was a theoretical physicist. And a theory or a theoretical person is not somebody that's doing scientific stuff. They just make theories. And they hope that somebody else will prove their theory. But that's not what real scientists do. If you look at Galileo, Newton, and we'll look at some of those other people here in just a little bit, these are scientists from hundreds of years ago. They actually did the real experiments. And so we'll have a chance to do that here in the universal model, do some of our own experiments, and to help us understand nature better. And that's explained there on the bottom of page 28. So in 2.5, we have the USM. Now, does anyone know what an acronym is? An acronym is what? That means something, right? If you hear NASA, most people just think that's the word. Well, that's actually an acronym. The N, the A, and the S, and the A all have specific meanings. Like a USM is a universal scientific method, okay? So the first letter of each word gives us the new word, which is USM, or the universal scientific method. So because we don't have a universal scientific method in modern science, we had to come up and develop one. So you can see here on page 30, okay, in the top right-hand corner, what the universal scientific method is. And to show that this method is legitimate and it works, is we use it throughout not just this book, but in volume 2 and in volume 3. And so this is one of the goals of the universal model, was to go through all the fields of science and show us how we can determine what is correct and what is false. And the way we do that is through first starting with a theory, then number 2, we make a prediction, and then we test that prediction and the theory, and then number 4 is you have to have an observation. It's very important that we just don't have an idea and think, oh, my idea is great, so that makes my thing correct, right? That doesn't how it works, okay? You can't just have an idea. You have to have a physical observation. That means you have to use your 5 senses, and then what you observe, like the light coming through our windows in this classroom, okay? We can say, I don't think that's coming from an artificial light. I think that's coming from natural light. Well, how could you figure that out? What you'd have to do is either go to the window itself, or you'd have to wait over time. If I stood right here, I can't tell where the light's coming from outside. But if I waited over time and I made a prediction like, well, if it's sunlight, what should happen is that light coming through is making shadows down here. Over time, they should move, because what does the sun do? Does it stay in the same place all the time? No, it moves. So I can make a theory here that this light coming through the window is sunlight, and then I can do an observation, and I can evaluate that observation, right? I can see the data, and I can go down there and track on the ground the shadows, and if they start moving, and then eventually the sun goes away because it's nighttime, well, then I can have a determination to know and evaluate that my theory was correct. And if it is correct, does the sun come up just one day a year? No. The next day, I would be able to come back and observe the same thing happening again. Okay? But because there's 365 days in a year and the sun moves a little bit, every day if we go mark that shadow at the same time, what happens over the whole year? Gradually, the shadow is going to keep moving, okay, throughout the whole year, and it'll change. Because the sun moves. In the wintertime, it goes down over here, and in the summertime, it's more overhead here. And that's because the way our Earth is going around the sun is we're in an elliptical plane, and it's not perfectly flat. We're on a tilt, and that's why you see this going back and forth, the sun changing through the seasons. So this is how we do the universal scientific method. We use these steps. And notice we're starting with a theory, but do we end with a theory like was back here in these other modern science methods? No, you don't end with a theory. This is the problem with modern science, is their endpoints are theories. And that's why they never have natural laws, because they're not even looking for the truth. Remember, a natural law is a statement of truth. If you have notes and are taking that down, that's one that you definitely want to put down there. The natural law is a statement of truth. Okay, so the next couple pages, and some parts we have to go through quicker than others, but they all explain those 6 steps that we just learned on there. And that's what it's talking about there. So once we get to 2.6, which is on page 34, we're now getting into scientific models. And we all know what a model car is, for example, right? Or a little model house. You can see it up there on the top of page 34. What does a model car represent? A car, a full-size car, right? Okay. Usually a little car will be like a 1 to 10 or a 1 to 50 on its representation of the size. In other words, it's 50 times larger than the model you have right in front of you. But the model is what? It's a representation of the real thing, okay? So it represents what we have in nature. And on page 34 there it says model, an organized representation of facts in a framework that we can demonstrate and explain. And remember, demonstrating is part of this physical side over here. Okay, it answers what, where, when, and who. And then when we explain something, we're going to explain how and why. Okay? On page 35 there, we have another section that talks about pseudo-theory and UM models. So first off, we even define what universal means. Universal means applicable to all people and all things. That's on page 35 there in the green words. So when we say universal model, the reason the model of the UM is universal is it applies to which sciences? All of them, correct. And that's important, that we don't have something that applies just to one little area, because this isn't how we learn from learning just in one little area. We want to learn all the areas of nature, because a lot of the answers in For example, the weather. To understand the weather, you have to first understand geology. Because understanding that there's water underneath all of our feet right now, if we drill right down where you're sitting, eventually we'll hit what? Water. That's right, because underneath the ground, when you understand there's aquifers everywhere, and it just depends how deep you go, you're going to hit one of those aquifers. An aquifer is what? It's an underground stream or river. That's right. And they're all over underneath the ground. And now we can't see them right here, okay, because we're on top of the ground, but what happens when we drill down? If we hit one that is connected to a fault line that's going this way, okay, and the mountain's over here on this side, when it rains and the water comes down and that falls into the underground river and then it comes way down here, guess what happens? If you pop into that, they call it an artesian well. That means the water will now pop out right out of the ground, right where you're at. You pop into that, you'll have water coming right out of the ground. It's under pressure. And that's because it's up higher over there and it's lower here, so it's pushing down with gravity and giving us our water. So a lot of you guys might have in your house or in your yard something they call irrigation. Here in Utah, they do this. I was from Arizona originally. We didn't have pressurized irrigation. But here you can have pipes and you open up the irrigation valve. And in Mount Pleasant, they kind of have a drought right now, right? So we have just one day a week they're watering. But when you open it up, why does the water just come out? Where does it come from? It's coming from the reservoir up on the hill, right? So it's at a higher elevation. That gravity is pushing and causing the water to come down through the pipes and then pop out in your yard and water everything. So these are things that once we understand how the scientific method works and how we can discover things, we'll want to use that method. And to make theories and then to prove them, we need to be able to make observations. And it should be reoccurring to pass the test of time. So we can also show that something is a false theory taught us fact. Because if we thought that water was coming from up here in the mountain, and then you kept having water come out, but then you went up in the mountain and that reservoir was all empty, well then that doesn't make sense, does it? So it's possible that the water coming out of the ground can be also coming from your city wells. They have drilled down and they have a well down there and they're pumping water out. So if you have water coming out of the ground, they call it domesticated water for your house, that's different water than it was coming off the hill up there. And the way you find out is testing where your line comes from. If the line going up to the hill is empty, then you know water was coming out of the well, and that's where your water's coming from. So there's ways that we can actually go in and observe those kind of things. So, page 38, I like this one here. We have some sand dunes. We're going to talk about sand later in the semester because sand is one of the most interesting things. It seems so simple, but it's real important to help us understand correct geology and how erosion takes place. But the statement at the top is real important. Science today, that means modern science, and we put that in quotes, okay, is ever looking but never expecting to come to the knowledge of the truth. That's because they're not looking for truth. We actually have quotes in here. If you want to go back and read the blue words, you can see where they don't believe that there's truth. Now, this is not all scientists, but the scientific leaders. And we explained that last week, that the scientific leaders took their own survey, and more than 9 out of 10 of them do not believe in truth. And that's because they don't believe in a deity. There's no creator. And therefore, because the creator is truth, they can't look for truth. So that's the problem with modern science. And this gave us what we call in chapter 3 the dark age of science, okay? Remember this big picture we talked about a little over here, okay? Well, that big picture comes from 2 individuals primarily, and that was Darwin and Einstein. So we talk about that here in a little bit. Matter of fact, beginning of this chapter, you want to go through, you don't have time right now, but go through and notice that we have definition for what the word science actually means and where that word came from. It means to know, okay? And it's a study of demonstrated truths and natural laws that describe and explain nature. And notice the describe and explain, how it comes back to the learning process. Okay? So this is real important that we see that we're actually coming back to this in all that we do, when just the definition of science, and the same thing with scientists, is one who describes and explains nature using demonstrated truths and natural laws. See, so this is what Einstein would have had to do, is he would have to demonstrate his theory was correct with natural law if he was really a scientist. So this is why it's important to be able to clearly explain how nature works. We have to also have a physical description of it that everybody can comprehend and understand. And those two words, by the way, I didn't put them up here, but this side is understanding. I think I'll write that here. Helps us remember. Understand, and this side we comprehend. So comprehension is an intangible thing. We comprehend how and why, and understanding is the physical side of things. The purpose of science down here on the bottom of page 40 is also really important, to describe and explain nature so that we can understand and comprehend it. So you see how the words all match and they all fit there and they make sense, and that's what's really important. So the next two pages, you see a bunch of different pictures of scientists there. Okay, what's interesting is these guys lived hundreds of years ago, and they gave us new natural laws. And if we go to page 45, we're going to see a book up here. So here's a little interesting story. I found this book through a real interesting, we were actually driving up through Wyoming and into Montana, where my wife's family is from. And I saw this, it was a big poster, billboard, that said that there was a technology place, a technology museum. And as soon as I saw that, I felt, remember we talked about the intuition that scientists can have, right? As soon as I saw that, I felt inside that I needed to go there, okay? We were kind of busy on our way up, and had things going on and so forth, but I told my wife, I need to go back because I didn't see the little details where this museum was. I stopped the car, we turned around, came back, I looked up at the billboard again so I could find out where it was, how far it was on the road we were actually on, how far away it was. And it turned out I went to this place, and when I was there, I ran inside, said, I'm just going to go in because I know I'm supposed to go here. I don't know why. This happens throughout the UM for the last 30 years. This is how the UM has come to be, okay? I have impressions like this, and these are what guides me and helps me to find the things that you find in the book. And this is a clear example. So I went in, and they had all these different technology stations. And I remember walking through the whole museum, and I didn't find anything that I felt connected to the universal model. I didn't quite understand. And we're going to talk about the difference between technology and science in just a minute, okay? So that's where we're going to lead to. But as I was going through, all of a sudden I came to the door right before you go out, and it had a little bookstore there, and there was a whole wall of books. And I felt drawn to this wall. And as soon as I got there, I went through. This is the book that stuck out to me. And I picked it up and looked at it. I didn't even open it. I just went up and bought it really quick because everyone was waiting in the car for me. And when I got home and read it, what I found was a very interesting thing. This is a book, they have all kinds of books of 100 individuals or people that either were musicians or maybe they were athletes. This particular book was about scientists. So I read through it, and what I did was took all the scientists in there and wrote down in a chart, which you can see here on page 44. If you look at that chart on page 44, you will find the scientists either made a new observation, that's what this first column is, or they made a new technology, that's what this column is right here, or they made a new theory, or a new law. This is a natural law, okay? And immediately, once I took all the scientists and put their names and what they did in here, I noticed this big, huge blank area over here, right, under the new theories. And what had happened is, like it says here, during this time periods, oh, by the way, this is all according to the time. There's the year 2000 up here in the top and 500 BC down here in the bottom. So this is over time. And so what you have before you got to the 1800s, what happened was the theories were tested, and either they got moved over here to the natural law column, or they were discarded. See? That's why there's no theories down here. However, in the last 150 years, guess what modern science has done with their theories? They've kept them. Why do they keep them? Even though they don't prove them, and most of them, if not all of them, have been disproven in the universal model. That's because they don't have any new natural law. If you look up here in the right-hand corner at the top, there's a dark area, and it has the white words, the scientific dark age. That's because in the last 100 years, we have literally been living in the dark with modern science. And the reason that is because there's not been any new natural laws discovered. So if we turn the page and look over here on page 40 through 5, you're going to see 3 important questions just to the right of this picture, okay? Are there more scientists today than 100 years ago? What would you say? Okay, yes. Next one. What do you think? Yes, we are spending more research money than 100 years ago. Okay, and third one. Obviously, today we have more technology than 100 years ago, right? So we have more scientists, more money, and more technology than 100 years ago. So why today do we not have any new natural laws? In your guys' lifetime, in your parents' and your grandparents' lifetime, they're not going to be able to name a new natural law of any significance. And that's because the modern scientists today are not even looking for natural law. And that's the problem. Okay? So, if we go down here on 46 and you look up Dark Age of Scientific Truth, there's 3 examples there. When you get a chance, if you haven't had a chance yet, make sure you read through each one of these. These are scientists that went against the grain. The universal model is going against the grain. All the other scientists out in the world today, they don't understand what's in the UM, okay? So we're giving examples of what other scientists had to do to overcome that. William Harvey and this Ambrose Paré, and then this last one here, I can't even pronounce his last name. Ignaz is his first name. But these individuals were doctors or they did other scientific work, and it was interesting in the medical science field how they were poo-pooed, meaning that they were told what they found was not something that was correct, like the dirty hand doctors. This is an individual that found when he went to work and do operations on people. Today, we just consider this obvious. The doctors wash their hands before they do an operation on you, right? And they wear gloves, right? Well, back in the 1800s, before him, you did not have doctors doing this. And they would go work on cadavers. You guys know what a cadaver is? It's a human body that's died, and they're learning about it. There was doctors that would go teach a class, and they would work on cadavers, and they'd walk right in and do a real operation right afterwards and not wash their hands. Okay? And the people that were getting operated on would die very easily because they get infections. And today we understand what bacteria is, right? You have to have a microscope and to see really small things like that, but they didn't know that back at that time. So these individuals that did things that helped progress science, they were turned down and were told that their theories weren't correct until time went by and people could actually confirm what they were doing, okay? And so the universal model is very similar. It's going to take time for other scientists to learn what's in the UM and to understand that the things that are in here are correct. So we got on page 48 there is an important principle, the simplicity principle. The simplest correct explanation is the best. So if there's a lot of explanations about something and some of them are really long and complicated, well, that's not the one we want to use. We want the simplest and correct explanation. And that's what we consider the best explanation. Page 50 there, we learn a little bit more about modern science and truth. The Dark Age of science on the bottom of page 50 in the green words began with the false philosophy that there is no truth in science. So we actually have quotes here. Right above it is the blue words. You can see what a scientist said. It says here, example of a philosophical truth trap comes from a 1976 Nobel Prize winner. Okay, his statement made in the year 2000 sums up the common dogma. You guys know what dogma is? Okay, it was held by many in science today. So this is a false idea that everybody was agreeing to. It says, quote, by definition. So notice what he's saying here. He's saying this is the way it is. By definition, science welcomes new evidence, new ways of thinking. Then he says it has no final truths. It is a continual quest and exploration. Well, that's the problem, is they're not looking for something that doesn't change. And like we talked about before, 2 times 3 was 6 yesterday, today, and tomorrow. And so it's important that we acknowledge that mathematics is correct and it's not going to change. The way we do math in our base 10 system is not changing. And it's the same thing with water inside the human being, right? Every living cell, actually, even in plants, has to have water or it can't replicate. This is why water is, we're going to find out, one of the golden threads that goes through all the science fields. It's very, very important. And on page 52, you can see the big picture of modern science that we've just been talking about today. Okay, and there's some quotes after that, by the way, if you want to read each one of these and the steps between these. We just put a couple in. There's hundreds, if you want to go online and look, of explaining that everything came from nothing. Here's our definition of intuition on page 54, the direct perception of truth. And also down here is a really neat story about how popular is modern science. I have a little story in there where I talk about my experience of coming to understand this. Keep in mind that I go talk to scientists and I take science classes when I was in college, and what you're reading here is not taught. People didn't understand why the general public doesn't go along with what modern science is teaching in most cases. And that's because we don't understand it. You can't explain something coming from nothing. And when you have an explosion, right, if I blew this book up, is all the little pieces going to come land and form a book that I can read again? No. Okay, so everything coming from a Big Bang makes no sense at all. On page 55 and 56, you'll see this diagram, and you have an explanation over here on technology and science. Who wants to tell me why they're different? Why is technology and science different? What does technology do? What is technology? A lot of people haven't thought about this. Well, this is technology, isn't it? Right? My phone. What would happen if my phone, I go to turn it on and it worked, 2 or 3 times out of 100 times? Am I going to keep using it? If 97 or 98 times out of 100 it doesn't work, you're not going to keep using your phone. Okay? So technology advances because it works. But in modern science, they can make a theory about how the craters got made on the moon, and everybody just accepts it because it's a great theory, right? That rocks came from space and made these holes on the moon. But there's a problem with that. And we're going to find out when we get into the hydroplanet model how those craters really got made. They weren't made by impact. When you have a high-speed impact, which is faster than 10 kilometers per second, that's like 10 times faster than a bullet from a gun. When a rock hits, it's like an atomic explosion going off. It gets so hot that it melts everything inside the crater. Now, has any human being ever seen a crater on this earth being made by a rock coming from space? No. And that's the problem. Modern scientists don't acknowledge that. They don't teach what I just said to you. You don't go to a class and learn how craters are really made. Now, we do know on a high-speed impact what happens inside a crater, because in the laboratory we've done this. In the laboratory, when they do high-speed impact, the whole inside of the crater turns to glass. And there's dozens of other reasons why the craters on the moon are not impact craters. And the same with the craters on the Earth. And the real problem is, scientists, have they observed these craters being made? No, we just explained that, right? That's the real problem, no observation. So in the scientific method, remember where observation is one of the key steps there? That's what they don't have. So this is the difference between science and technology. Technology is the creation of tools that help us understand nature better. But it's not nature itself. Science actually comes up with new natural laws. See, true science describes and explains, it's right here again, nature using natural laws. In contrast, modern science has fallen into the dark age in the last century by relying on scientific theories that have been unable to correctly describe and explain nature. This has led to the mingling of technological success with scientific theory, lending to an air of credibility as compensation for the failures in science. So what that is saying is, because this phone works, and you'll hear people saying, oh, wow, scientists made this phone, it's so great, and la, 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 la. Well, no, it was technologists that made the phone, okay? The phone works because of technology, not because they understand the craters on the moon. I go in here and Google, how are the craters on the moon made? Unless you go to universalmodel.com, you're not going to find the right answer in the whole world. See, this doesn't tell you how things work, okay? That's what science does. Science is the mechanism that gives us the correct way things work. Our bodies are nature. They're natural, right? So they are what science is about. Medical science is about the understanding and studying of the body, okay? But the technology is going to be something like when you get a broken bone, sometimes it's so broken to keep it in line, they have to put a pin inside it and hold it in place. That's a technology. And those technologies have helped people's bones heal and they can walk and run again, because if that bone was broken and smashed completely to smithereens, the person never walks correctly again. But because now they have the technology to put that bone and hold it all in place for it to heal back in alignment, well, that's something that helps the body. And so that was a man-made, technology are man-made things, okay, such as computers and cars and things that help us, they're tools. A telescope and a microscope, that's a technology. And so there is other sciences which your general medical science does not agree with. If you go to volume 2, in the very back under the medical science, you'll see we bring all these up. Is it irisology, where they use the iris, and you use your hands and your feet, and there's different ways that we can understand the energy systems that go through our body, okay? By the way, that's one of the discoveries in the is where does the electricity come that runs through all the nerves in our body? A medical doctor can't tell you today, and we give an answer to that in that chapter, okay, in the medical science chapter. If it's a true explanation, you can actually make a law from it. We actually have several new natural laws in that medical chapter that help explain that. So when it's a tool, such as like the brace we talked about, putting on the leg to help hold it in place, that's the technology, okay? But when it's something that is describing or explaining, okay, and we're learning from this correctly, and it's repeatable evidence, so we can actually make natural law from it, then we're doing science, okay? All right, so we're going to go to our last section here. We only have a little bit more time left, and this is the scientific revolutions. This is not a long chapter. It's quite short, actually, but it has a real important concept here. This individual here at the top, you notice his name's Thomas Kuhn. And here's a quote by him. It says, led by a new paradigm, scientists adopt new instruments. That instrument, by the way, is the technology we just talked about, and look in new places, Even more important, during revolutions, scientists see new and different things when looking with familiar instruments in places they have looked before. So he gives us some key points here. He wrote a book called Scientific Revolutions, and he was the first person to use the word paradigm in science, and this became a word that we all started using back in the 1960s when his book came out. So the first thing we ought to ask on here, what is a scientific revolution? Well, he explains down here under the blue quote on page 61, by disguising such changes, the textbook tendency to make the development of science linear hides the process that lies at the heart of the most significant episodes of the scientific development. So you can see this diagram here. This is what modern science tries to teach us, that over time, that science just gets better, that we just learn more and more things. Well, what happened in the last 100 years with no new natural law? Well, there's a problem. We're not progressing, okay? So if we turn the page over here, you're going to see where there's scientific revolution. And every time we have a revolution, this arrow, we thought that was just going up like this, and actually they're going flat until we have a revolution. And these revolutions are primarily when new natural laws are discovered. This is why we have the Copernican revolution, the Newtonian revolution, and these revolutions are where natural laws were discovered. And this gives, when a new natural law is understood and everybody can see it and it's describing, well, now we're able to advance in our understanding. And so he also, Kuhn, he describes that there's a crisis for this to take place. For us to have this jump, we have to have a period of no learning. And that comes from a crisis. And the crisis is this, is the big picture of modern science. Obviously, everything doesn't come from nothing. Everybody gets that's searching for truth. Okay? And that's caused the crisis right here. So with this crisis, the UM is now poised to give us new discovery that we've never had before. This is where the question mark up here, and as you go to read the UM, that's what all this is. It's the new discovery, the biggest vertical leap that we've ever had, describing all of the new natural laws. And here at the end, you can see this is an important quote. The unique claim is that modern science languishes. It means it just sits around in a crisis with all fields, and notice the absolute word there, all fields, poised for a universal revolution. So this is the unique claim about the that you don't have any other book stating. And that is that all the fields of science, archaeology, biology, chemistry, geology, paleontology, astronomy, physics, all of these fields are poised to have a revolution because they're all interconnected. Nature isn't about anology. Remember last time we had the discussion of what omnology is and how you're all becoming omnologists, right? Do you guys remember that? My daughter, who was about 12 or 13, when she was in class trying to understand what the was, what her dad did, wasn't able to tell her friends until we got together and understand that an omnologist is someone that studies all the natural fields of science. And so omnology is the study of all the natural fields, and because of that, now we can understand things like we explained before, the weather. You have to understand what's underneath the ground and correct geology before we can understand the weather and be able to predict with weather, where the clouds come from and where the high pressure systems come from. This is something that's from a whole nother field that's not even about the atmosphere. It's all about what's underneath our feet. So I hope you guys have had a new understanding today of what this is really, once again, an introduction of all the fields of science. We're going to start next week with learning about the magma pseudo-theory. Well, thanks so much for coming, and thanks for learning about the universal model.
For more information, please visit universalmodel.com. Use the coupon code UMYouTube to receive 20% off your purchase in our store.